All right, so here is a practice exam. Again, this is not to give you an idea of what the exact exam would look like, but just a quick synopsis of a couple of questions that I wanted to make sure that we all remembered for the exam. Of course, you'll have more time, an hour and a half to complete the exam. Bring your calculators. So let's just do a quick look at the solutions using AI to help us figure this out. So I'm going to upload a PDF of the solutions. A PDF of the problems so that AI can give us the solutions. Alrighty. And again, here's the exam. So I'm just gonna go one by one. So I asked, give me the solution to problem 1A. Okay, and let's see what we get. So we have our function, the domain, an explanation, basically setting the denominator equal to 0, and where that doesn't happen is our domain, and they just gonna go ahead and give me everything. Okay, not a problem. 1B, vertical and horizontal asymptotes. Alrighty. So for the vertical asymptotes, you want to look in the places and spaces in your domain where there's a gap. Those are the only possible places we have vertical asymptotes, which is 2. However, in the numerator, you also get a 2. So one thing, I was working with some students yesterday, one thing that we saw was that if you're able to cancel the numerator and denominator, right, you have to take a look and see what's left. When you cancel the numerator and the denominator, in this problem, you actually still have an x minus 2 that's left. So ChatGPT tripping, right? This is wrong. You don't have a hole there. You have a vertical asymptote. If there was only a 1 in that power, right, then you would still have, then you would have a hole because there is an x minus 2 factor in the numerator. However, because the x minus 2 remains in the denominator, it is a VA. Graph it, sketch it, you will see there's a vertical asymptote of x equals 2. When you report your vertical asymptote, you should say x equals 2 as your vertical asymptote, all right? Horizontal asymptote, it's saying that the numerator is degree 3, denominator is degree 2, and so we do not have an asymptote for the problem in that case, right? Horizontal asymptote, because for the horizontal asymptote, you're taking a look at the limit as x goes to infinity. We have a slant asymptote, but that's not something that we're going to be worrying about in this class, right? And then as far as the discontinuities, which is 1C, we have x equals 2. Again, because the only places where there's a discontinuity is in the places where there's a gap in the domain. Now, the nice thing about AI is you can keep, probing further and more deeply, and I'll just say, show me the factored form of f of x. So we can see exactly why ChatGPT was wrong when it came to the vertical asymptote, all right? Okay, so denominator's that, pull out an x, and they give us all the steps in terms of how to factor to make sure we get the 6, the 7, the 2. Okay, so there's our numerator. So the fully factored form, the original function, is this. And this is what I was saying earlier. You can cancel the x minus 2 one time, but there's still one left. And so this is our fully factored form, okay? Now, the cool thing about this fully factored form, and actually one of the students I was working with yesterday is the one who pointed this out, is that when you find your horizontal asymptotes, right, what you want to do is you want to find the limit as x goes to infinity of the function, right? So really, you don't have to start with the original function. You can start with the factored form of the function. I should say simplified form. When we take the limit as x goes to infinity of this, it's a little bit easier than taking the limit as x goes to infinity of this, okay? So, again, depending on your preference, you can work with it either way. All right. So you do have a horizontal asymptote. I don't want to check ChatGPT on this right now. Stay tuned for a later video. And by the way, like and subscribe. Okay. So that is question number 1. Question number 1, looking at all these different aspects of this function. Okay, obviously there's work behind each one of these answers. Be confident in terms of how to do that work for each of these. Okay, domain, set the denominator equal to 0, see where that gap is. Vertical asymptotes, identify where the denominator is 0 and the numerator is not 0, right? After it's fully factored, okay? And then horizontal asymptotes is the limit as x goes to infinity. This continuity can only happen in the places where there's gaps in the domain. So I hope that makes sense. One last thing I would like for ChatGPT to do is show me, using limits, how to find or to determine whether there's a vertical asymptote. Okay, so let's see. Actually, this might actually call it out. And so in the factored form, we see this right here. Number 0 typically says we're going to have to, okay. So now we look from the left and from the right. So there's a very important aspect. So you can know, is my function going to positive infinity or negative infinity? Okay. And so this is the type of thing that I would like to see, is once you identify there is a vertical asymptote, which you know because there's still an x minus 2 left after it's fully factored and canceled out. And obviously you know because you graph it. Very important. Graph it and see. You already know the answer when you graph it. But then additionally, I want you to just show this limit right here, negative infinity, limit is positive infinity. As long as one of them is in infinity, you got a VA. All right, so I think we have taken a solid look at question 1. All right, cool, great. Now show me the solution to problem 2. Okay, let's reacquaint ourselves with problem number 2. Problem number 2 is we have a particle. We have the position given by this. We want to sketch a graph, average rate of change, definition of derivative, and a more direct method, which is using one of our derivative rules. I can't state it enough. The only time you need to use the definition of the limit x. The only time you need to use the limit h goes to 0 is when it says definition of the derivative, which is C. D, we're straight up using probably the quotient rule. Okay. All right. So here we go. We're able to see a graph. So sketch a graph of the function. Okay, right there, which is cool. And then we find the average rate of change. Remember, the average rate of change is when you found y2 minus y1 over x2 minus x1. 2 locations on the curve. That's the difference. That's your rise. 2 inputs is your run. And then you find it by plugging in s of 0 into the original function, right? Into that original function, plug in 0, you get 0 plus 1 over 0 plus 2, 1/2. And then you plug in 2 and get 5/4. Average rate of change, boom. Next, definition of derivative. Alrighty. So what it did was it took a nice little shortcut and I believe it just used code. It just did some code for us and made it happen to make that happen. So there's an awesome thing about code is that you can get answers to complex questions really easily by knowing how to program. Hopefully, not hopefully, that is a skill as STEM majors you will all learn and will all need, and something that we'll talk about more as we go throughout the course and thinking about data science and the connections to that. But anyway, our answer is 1/3. Okay. Maybe we'll ask a follow-up to see that step by step. Okay, more direct method will be the quotient rule. Now, even ChatGPT knows what Soiree wants to see. Okay, now they using V's, I use F's and G's, but it's all the same, right? Our U is a numerator, V is a denominator. U prime is 2, V prime is 1. I want to see this. I want to see this. I want to see this. 7 points just to get to that point, right? And then you can proceed. The nice thing though for this is that we're evaluating at a point, so we just plug in and we don't need to like simplify the algebra. So let's just plug in right now. And so it's 2 times 3 minus 3 times 1 over 3 squared, 1/3. Matches the previous result. Bet. That's exactly what we're looking for. All right, interpretation. What is this 1/3? It is the instantaneous rate of change. Very good. So that is a quick look at number 2. Let's see if we can get more of the steps, right? So can you show me the step-by-step math for part C. Okay, so obviously this is not something that we will be doing tomorrow on the exam. We will not be using ChatGPT to do the exam. That will be amazing, but that's not gonna happen. So instead, we can use ChatGPT before the exam to help us study, right? As you study, do what you would do on the exam. Do it by hand, paper and pencil, stylus and tablet. But to be able to get quick feedback, right? That's where this is useful. Get quick feedback. Did I do it right? Did I do it wrong? Okay, so here's a process. We got S of 1 plus H. Plug in 1 plus H. Simplify. S of 1, we find that value as equal to 1, right? You do the difference quotient, subtract, and what we're going to do? We're going to combine. If we have something like this, we're going to combine. FERC, combine. H plus 3 denominator, something like that. Now I see that H in the denominator, sneaking into the problem. That H in the denominator, you will always get canceled, H. You will always get canceled. That always happens, always. If that H does not get canceled, you did something wrong, period. Why? Because this is a 0 over 0 if you do the DSP. So I know that H in the denominator, he's going to get canceled, right? He's going to get canceled, literally. And so anyway, you simplify, you get 1 over H plus 3, DSP, 1/3, same answer. Okay. Let's conclude this by looking at question number 7, which should be a 3, but forgot to fix that. So awesome. Show me the solution to number 7 now. All right. Don't be confused. Oh, see, come on now. Oh, I see. I hit the limit. Dang. That's cold, ChatGPT. That's cold. But guess what? You can't outplay a player. All right. I'm going to go to my other account and just upload the document from here. Okay. So we got this. So I got like 18 Gmail accounts precisely for things like this. I don't like paying money for apps that should be free. Show me the solution to the last problem. Alrighty, so that's our function. That's our derivative using the product rule. And again, ChatGPT knows exactly what Soiree wants to see. Got my U and my V, even though for me it's F and G. And so we get our derivative using the rule, because I see a function times a function rule, right? Now, in order to find the equation of the tangent line, they're using this format, but instead of like f of a and f prime of a, we usually say y1 and m. However, this is pretty good because in this problem, we need to know that when you're not explicitly given y1, you just go ahead and find what the value of the function is at the x value, and that is your y1. So that's a pro tip right here that ChatGPT is hooking us up with. We already know f prime evaluated at the function is going to give us the slope, and so this is what our answer is. Because I say do not round, that means I want to see the precise answer, which is just don't use a calculator. Plug it in and put it right there. Alrighty, so hopefully that was helpful in terms of you checking your work, but also understanding the steps and the process to getting your answer. Don't forget to like and subscribe. Peace.